Hey guys, Taylor here, and today I'm going to be talking to you about the unit circle. The unit circle is a circle on a coordinate plane with its center at 0, 0 and a radius of 1. I'm going to be spending most of the time talking about the three most common sections of the unit circle and how to find their radian measures and coordinates. Then I'm going to use the patterns from those to help me find the rest of the sections. The first section we'll be talking about is the 30-degree section. And the first thing we need to do is convert it to radians. So a full circle is 360 degrees, which is equal to 2 pi radians. And since 30 degrees is 1/12 of 360 degrees, it's also equal to 1/12 of 2 pi, which is pi over 6 radians. So that's the radian measure of 30 degrees. The next thing we need to do is find the coordinates of this red point here. First thing you need to do for that is draw a straight line down from the point to the x-axis. And that will make a right triangle. But not just any right triangle, this is a special triangle, a 30, 60, 90. And what's special about that is that the shortest side of it is 1/2 of the hypotenuse. So our y is going to be 1/2. And what we're trying to do here is find the x and y coordinates. So our x coordinate is going to be on the x-axis and our y coordinate is going to be on the y-axis. In order to find the x coordinate, we need to use the Pythagorean theorem. So 1/2 squared plus x squared equals 1 squared. X squared equals 1 squared minus 1/2 squared. X squared equals 1 minus 1 over 4. X squared equals 3/4. X equals square root of 3 over 4. So x equals square root of 3 over 2. So our coordinate for this point is square root of 3 over 2 and 1/2. The next section we'll be talking about is 45 degrees. So first we need to find the radian measure, and since 45 degrees is 1/8 of 360, it's also 1/8 of 2 pi. So 1/8 of 2 pi is equal to pi over 4. So that's our measure. Next, we need to find our coordinates. So draw your line. And this makes a different kind of right triangle. This one's a 45, 45, 90 triangle, which means it's isosceles. So our Pythagorean theorem is going to look a little different this time. Instead of being a squared plus b squared equals c squared, it's going to be a squared plus a squared equals c squared, which is 1. So that makes it 2a squared equals 1 squared. A squared equals 1 over 2. A equals square root of 1/2. But the problem with that is that it has an irrational number on the bottom, and we don't want that. So the square root of 1/2 is actually equal to the square root of 2 over 2, and that's what we want. So both of these, x equals square root of 2 over 2, and y also equals the square root of 2 over 2. Pretty easy. The last section we're going to look at is the 60-degree section. So first, 60 degrees is 1/6 of 360 degrees, so it's also 1/6 of 2 pi, which is pi over 3. Now to find the coordinates. Draw your line. And that makes yet another special triangle. But this one is actually the same kind of special triangle as the first one, a 30, 60, 90. Now look at this for a second. Does it look familiar to you at all? Because it should. This triangle is actually just a flipped version of the first one. It's just been rotated up. So what happens here is that the short side is still 1/2, but it's going to be our x-coordinate instead of our y-coordinate. So it's basically flipped. So our x is going to be 1/2, and our y is going to be the square root of 3/2. And that cuts out a ton of solving time, which is awesome. Alright, so now that we have our 3 points, we can use them to find the rest of the coordinates. You'll notice that I already filled in the radian measures for the rest of the points, and that's actually really easy to figure out. I just didn't want to do the math on camera because it would take me a while. For example, if you have pi over 6, that's equal to 1 pi over 6, so you can count like this. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. There you go. And that same concept can be applied to all points. So that's how you fill in the radians for the rest of the circle. Next, we need to find the coordinates of the other points, and that takes a little more work. The first step to that involves trigonometry, and it might not seem connected at first, but I promise it's important later on. So the first thing you need to know is that this point, or this coordinate, the x-coordinate, is the cosine of pi over 6, and this one, the y, is the sine of pi over 6. Why is that? I will show you. So let's remember SOHCAHTOA first. So for the cosine, the x, it's adjacent over hypotenuse. So the adjacent of the angle is x over the hypotenuse, which is 1. So that's equal to x, which is the x-coordinate. So that's why it's cosine. And the same thing applies to y, except it's opposite over hypotenuse, so it's y over 1, which is y. So the reason why you need that is to figure out whether the coordinates for each quadrant are positive or negative. And you use a little chart that looks like this. C, A, S, T. This chart tells you which of the coordinates are positive and which ones are negative. In this quadrant, all of them are positive. In this quadrant, sine is positive. In this quadrant, tangent is positive. In this quadrant, cosine is positive. So, next step, before we add positive and negatives into this, how do you know what the coordinates are in the first place? It's actually really easy. You can use the coordinates for these 3 points we found earlier for all the quadrants. Alright, so I know this doesn't look realistic because really, how can all these points be exactly the same? It doesn't make sense because some of them have to be negative due to being in different quadrants. That's when this little chart here comes back in. So if in this first quadrant, if all of them are positive, great, it matches up. Second quadrant, only sine is positive, which means that cosine, the x-coordinate, has to be negative. Moving on to the next one, only tangent is positive, which means both cosine and sine are negative. So both of these have to be negative. In the last quadrant, cosine is the positive one, so the x is going to be positive and the y is going to be negative. So that completes that set of coordinates. The last ones we need to find are the quadrantal angles, and those are the ones that can't be solved with the triangle, but you don't really need to, since you know that the radius of this is 1. This point has to be 1, 0. This point has to be 0, 1. This point is negative 1, 0. And this point is 0, negative 1. And that's our unit circle, filled in. Thanks for watching, and I hope this helped a little bit.